The future of work is automated. Welcome to Aivora.
In 2012, a paper landed that quietly rewrote the rules of video game lighting. It wasn't about ray tracing or global illumination. It was about something simpler: how dark corners get. But here's the thing, the shadows in those corners are fake. Your brain sees them as real, but the math behind them is a lie. And nobody tells you the seams are showing. Which means the entire industry spent years building an illusion that breaks at the edges. So the question is, how did we get here, and why do corners not look like that? Let's start with the basics. Ambient occlusion is the soft shadow that forms where objects meet. Think of the dark crease where a wall meets the floor. In games, that shadow sells realism. Screen space ambient occlusion, SSAO, was the trick that made it cheap. Instead of tracing rays, it uses the depth buffer from your current frame. Fast, but shallow. It only sees what's on screen. And that's the problem. When a corner extends off screen, SSAO doesn't know it exists. The shadow just stops. Corners become half-baked. The illusion of depth breaks. Enter McGuire, Osman, and their 2012 paper, Corners Don't Look Like That. They proved SSAO fails exactly where your eye expects consistency, along edges of the screen. Look at Crysis from 2007. Revolutionary graphics, but pause on a corner. Notice how the shadow vanishes near the edge of your screen. That's the exact flaw McGuire's team described. Battlefield 3 ran Frostbite with SSAO. Dark corners looked great in the middle of the frame. But pan the camera fast and the shadows pop in and out. The brain registers the glitch even if you don't. Halo 4 tried its own version. Same problem. Corners near the edges of the screen looked washed out. The secret was that the game only had half the geometry data to work with. If this is the first time you're seeing the cracks in your favorite games, drop a like. It tells YouTube to show this to more people who want to understand how graphics really work. But the industry didn't stop. HBAO, horizon-based ambient occlusion, came next. It samples more directions. It helps, but the core problem remains: if the geometry isn't in the frame, you still get fake corners. Then came VXAO, using voxel cone tracing. It uses a cached world, not just the screen. Corners finally held their darkness. But it costs more performance. Most games still default to SSAO. Now ray tracing offers true ambient occlusion. It traces rays from every pixel, hitting real geometry. Corners are fully simulated. But RTX is still a premium feature. Most games on console still rely on SSAO tricks. Even Cyberpunk 2077 uses a hybrid. Ray-traced shadows for some, SSAO for others. Look closely at door frames near the edge of the screen. The illusion of depth still fades. Corners don't look like that. The next frontier is AI denoising. Neural networks can guess the missing corners. But they hallucinate details. The truth is, no trick is perfect. Every solution trades accuracy for speed. If you're building games or just love understanding the hidden math behind pixels, hit subscribe. I break down the secrets of real-time rendering every week. No fluff, just the real tech. So here's what I found: SSAO was a brilliant hack that fooled an entire generation of gamers. But corners, those tiny meeting points, exposed the limit of screen space. The paper changed how we think about realism. Next up, why ray tracing still can't fix everything. We'll look at the hidden cost of perfect lighting, noise, denoising, and why your GPU screams. Subscribe so you don't miss the real story. I'll show you benchmark data from actual games, reveal the denoising tricks that add lag, and answer once and for all: is ray tracing worth the frame rate? Hit subscribe to get that deep dive.